Hello, this video is going to be on reference triangles and reference angles. So a reference angle is always acute, meaning it's always going to be less than 90 degrees, less than pi over 2, less than the approximation 1.57 radians, and it's always positive. It is the angle that is found that's between the terminal side of the given angle and the horizontal axis. Right? So there are many ways to find reference angles. One way is to match what you know to what's given, and what you know are these reference values. Now the reference values that I know are always less than one revolution, but you can match what you know to what's given. So let me do an example of that so you see what I mean. Suppose I want to find the reference angle for 657 degrees. Now, I don't really know right offhand where 657 degrees is. So here's what I have to start. I start with what I know. So what I know is 0, 90 as I'm rotating in the positive direction because this angle is positive, 180, 270, and 360. All right? But I have to keep going because 650 is higher than 360. So if I add another 90 degrees to 360, I'm going to get 450. So 450 is coterminal to 90. Add another 90 to 450, and I get 540. Add another 90, I'm going to get 630. And add another 90, I'm going to get 720. So now I've matched what I know to what's given, because now I can say where 657 should be. It's going to be somewhere between 630 and 720. So what's happened is I've rotated once around the circle and then some more. So let me just go ahead and show you what that looks like. And this is about 27 degrees. It is 27 degrees more than 630, which is about 30 degrees. So we rotated all the way once to 360, and then all the way again, all the way out to here, about 30 degrees more, right? 27 degrees actually. All right, so there's where my angle is, and it's 657. Now, this is the terminal side of the angle. What I need to do to find my reference triangle is drop to the x-axis right there. This is going to be my right angle. This is my reference triangle right here. And the right angle that I'm looking for, the reference angle I'm looking for is this right in here. It's the angle that would be the motion from the terminal side of the angle that's given and the x-axis. It's this motion right here. And you can see with no matter what quadrant you're in, they're always going to be less than 90 degrees, and then you just make them positive. So if I now want to find what is this motion, it's the difference between 720 and 657, or the difference between 657 and 720. So let's take 720 minus 657, and you get 63 degrees. That is my reference angle. Now let's take a look at, instead of matching what I know to the given angle, I want to instead go ahead and do this problem where I match what's given to what I know. And I do prefer this method, so I'm going to do all of them like this so you can see what I mean. So in this case, I know, starting out, that 657 is more than what I know. 360 is one revolution, and I know all the values for one revolution, the reference values. So I'm going to go ahead and find the coterminal angle for 657 that is less than one revolution. So I'm going to subtract 360 as many times as I need to until I get a value that's less than 360. And what I see is that the coterminal angle for 657 is 297. Now that's something I know. So when I look at my circle and I say, oh, okay, I'm going in the positive direction. Here's 0, 90, 180, 270, and now 360. I know 297 is beyond 270, and it's 27 degrees beyond, so I know I can just do this and say, aha, here's where my angle is, and now I can work and find my reference triangle. So I drop the x-axis. This is my reference triangle, and I need to find this reference angle. So now all I have to do is say, oh, well, that's the difference between the motion from here 297, right? It's this, 297 to 360. So let's find that difference. And that ends up being, of course, the same 63 degrees. So this is the method I prefer, is to first, if I have a given angle that is more than one revolution, I find the coterminal angle that is less than one revolution, and then I drop to the x-axis and find the difference between the given angle and the closest angle on the x-axis. Okay. So now let's go ahead and do some more. Here's another example. Find the reference angle for negative 2 pi over 7. Now, I know that one revolution would be negative 2 pi in this system. We're dealing with the radian system with exact measure with pi, and we're going in the negative direction. So, essentially what we have then is we are looking at negative 2/7 of 1 pi, or you could think of it as 2/7 of negative pi, right? So we're going in the negative direction. Here's 0. Here would be negative pi over 2, and here's negative pi, right? So I'm wanting to divide into sevenths. I want to divide this portion, which is 1 negative pi. I want to divide it into sevenths. So let's go ahead and do that. Here would be about 1, 2, 3, 4, 5, 6, 7. So technically this is like negative 1/7 pi, negative 2/7 pi, we already found our angle, negative 3/7 pi, negative 4/7 pi, negative 5/7 pi, negative 6/7 pi, and here negative 7/7 pi, right? Which is negative 1 pi. So we've already found this. I just went beyond what we needed to, but just to show you. And now what we really are saying is that we have rotated here, and starting at 0, we rotated to negative 7th pi. So we did this. And here we are. There's my angle. And what I want to do is drop to the x-axis, right? This is my reference triangle, and I want this angle right there, the reference angle. So technically it's the difference between negative 2/7 pi and 0, but you just got to make it positive. So negative 2/7 pi minus 0 is negative 2/7 pi, but we need to make it positive, so it's 2 pi over 7. All right. Next example. Find the reference angle for 14 pi over 3. Okay, so here, this is more than one revolution, right? Because 14.3 is greater than 6.28, which is the system where it's an approximation for the radians. So I need to back out my full revolutions. So if I say 14.3 and I subtract 6.28, subtract another 6.28, I will end up with 1.74 radians. Now, where is that? Now that this is something I recognize, I say, oh, okay. Here's 0, here's 1.57, here's 3.14. So I know I've rotated here in the positive direction, passing 1.57, until I get to 1.74. Again, I'm not going to go through finding exactly where it is. Let's just say it's somewhere here, right? 1.74. I drop to the x-axis. This is the reference angle that I need to find right here, right? And so I'm looking for the motion, right? I'm looking to find the motion from this given angle, now 1.74, to 3.14. That's what I'm looking for, right there. So all I have to do is subtract 3.14 minus 1.74, and 1.4 is my reference angle. Okay. Example 5. Find the reference angle for negative 8.9 radians. And again, one revolution would be negative 6.28. I'm going in that negative direction. So I know I'm going more than one revolution. But I don't really like to work with the negatives so much. So I'm going to go ahead and say, I'm going to work with it in the positive. 8.9 minus 6.28 gives me 2.62. So the coterminal angle for negative 8.9 is negative 2.62, because I want to retain that direction. All right. So what's happening then is I'm rotating in the negative direction, starting at 0. All right, and I go all the way around. That would be negative 6.28, and then I keep going another negative 2.62. So I know this is negative 1.57. This is negative 3.14. So negative 2.62 is somewhere in this quadrant. So let's just say it's here, which it may or may not be. Again, I'm not being precise. But essentially what we've done then is we've gone in the negative direction, 6.28, and then some right there. That's actually our rotation. But this is where our terminal side of the angle is. We drop to the x-axis, and let's see here. This is our reference triangle, and this is the reference angle that we want right there. So it's actually going to be the difference between negative 3.14 and negative 2.62. And technically, if you want to be really, really precise, if you wanted to work in the negatives, you would do something like this. The absolute value of negative 3.14 minus a negative 2.62, or you could do the other way around, negative 2.62 minus the negative 3.14, right? You do all that, and you're going to get the same answers if you just work with them as if they were positive. 3.14 minus 2.62, and it gives you 0.52. That is your reference angle. So you could do it in a more complicated way, but I like to simplify it. So I work with the positives, and you know your reference angle has to be positive, so there you go. Example 6, find the reference angle for 2 pi over 5. Okay. So here, we know that this is less than 1 revolution. Let's go ahead and find out where it is on the circle. So essentially this is 2/5 of 1 pi. So going in this direction, this is 1 pi. So I would end up here. But I want to divide this into fifths and take 2 of those fifths. So let's say 1, 2, 3, 4, 5, right? So we're here somewhere at 2/5 pi. There's our angle. We just rotated that way. Drop to the x-axis, and this is our reference angle. We would start at 0. So I just really need the difference between 2/5 pi and 0, which is 2/5 pi. That is my reference angle. Okay. And now our last example, example 7, negative 3.7. Now again, this is less than 1 revolution, so let's find out where we are. Starting at 0, going in this direction, negative 1.57, negative 3.14, negative 4.71. So we're rotating around in this direction, and we're somewhere in here. So again, I always tend to draw them almost as if they're 45 degrees. That's not accurate. You could do where am I and find it. But essentially, we have rotated. The actual rotation is this. Okay? But we're using the reference triangle and reference angle. So you drop to the x-axis. What I'm looking for is this motion in here. So this is negative 3.7. And I want us to find out what is the difference in the motion from negative 3.7 to negative 3.14, this one here, or from negative 3.14 to negative 3.7. You can look at it any way you want. But that difference then, again, I like to work with the positives, is 0.56, and you make sure it's positive. That is your reference angle. Thanks for listening.